So we start with the function f. And range of f. Okay, so given a subset of Rf, what we call preimage. Okay, so it looks like the inverse notations, but what is this function? So this is a function, all x in the domain. For that, fx is in A. Okay, so give you an example how to determine preimage. Okay, so this is how we use our inequalities. Okay, example. So find the preimage of, say, our A is there, for example. Okay. All right, so what we looking for is this one. Okay, so what is this? This is a x such that the function belong to A. That means the f of x between 1 and 3. Okay. So how is 1 and 3 there? Okay, so this gives you an inequality. So this, let's compute this one. This means f of x is square root of x plus 2, 1, 3. All right. Because this is all positive numbers, then we are safe to square them. Why squaring them? Well, to get rid of the square root. Okay. All sides are positive. Okay, so what you have is, right? So this is between 9 and 1. Okay, so you can solve them easily here. So x is, and let's see, is 7. Okay. All right, so this is our preimage. So the preimage, is, see, this is -1, 2, 7. Okay, so that's the preimage. So this is how the inequalities become handy. Okay, any questions?
Can you scroll a bit upward?
Oh, yeah.
Upward again.
Okay.
Thank you.
So the preimage is something that, well, say this is the domain. This is the range. That's the functions. All right, so if we pick something inside the Rn, inside the range, so the question is, which part of the domain falls into this part? So this is what we call the preimage. Say this is a preimage of F, preimage of A under F. Okay. All right. So let's speak more about the preimage. The thing is with preimage is that with compositions, okay, so we have, say we have F first, and EF, RF, and then we have, say, this is the G going to RG. Okay. And going directly from DF to here is the compositions. What is compositions? F first and then G later. So F, G follows F. Okay. Now the question is, what is the domain of the compositions? Okay. So in this case, let's see. The problem is that, well, if you going from here, for example, and lands here, and then by G you come to RG. All right. But in other instances, from here you falls here. All right. So there is no way you can continue your journey to here. All right. So this is a dead end. So here. What happens to this one? Stuck. Sorry. Resume recording. Okay. Now, and where the instance you start with the one with green here, and you end up with here, for example, there is no way you can continue your, say, your journey here to RG. Why? Because you didn't fall here. Okay, no way. Okay, here. All right. So when you find the domain for the compositions, it is the one that the everything that falls to here. Okay, so we need to find the preimage of this part under F. Okay, so this is the, okay, so look, this is the RF. So there you go. This is the domain of G. Okay, so let's compute some example. Uh, okay, and then say square root. Okay, so let's do the let's compute here. What is df? Oh, find say this one first. G later. Okay. All right. GF. So that's the df here. The domain is, let's see, what kind of x can you plug into this formula here?
Any real number?
Any real number. Good. And the range. Sorry. All right. Is there any restrictions to the range? Because you take absolute value, then the
Cannot be
value should
negative?
be non-negative. There. Okay. And key. All right. So then the square root put restrictions. You cannot put a negative numbers. Right? So there we go. And the similarly, this is also the range. Okay. So in this case, let's see what happened here. Let's see. This is F first. F is, let's see, this is the whole thing. And F, and then G. Okay. Let's see, G. Okay. Let me just take another other color. Actually, this is the same thing. This is G. Okay. Yes. Yeah. Okay. So in this case, there is no problem because you see that the red one is the G, the blue one is R F. Okay, so here's RF exactly match. Okay, so first thing is that is defined. since it's not empty. Okay, and we need to find the what is the key anyway? X is, see the formula. F is computing the absolute value. So G of absolute value. Okay, so G is taking square root. So this becomes square root of okay. So in this case, you can go directly from, let's see, F first, followed by G. Okay. So in this case, what is preimage? Domain of, okay, so that's the preimage, yeah, of sorry, which is, okay, but we know that this is the range of F anyway, the whole range. Okay, so that's the reason why the inverse pre-image of the range is the domain in this case. So this is the, again, this is the whole thing. Okay. But sometimes you have some restrictions. Okay, another example. Let's see. Let's do something. Okay. And okay. Let's see. Let's do something like this. Determine, find domain. Compute the key follows F. Okay. And its domain. Okay. So how to find the domain and range of F in this case? Let's see. It's about let's. We can how you factor this one? Oh, sorry, not 3. This is minus. Okay. So when you factor, you get what? Minus 3 x plus 1. Okay. Okay. So you see this is the domain. All right. Okay, you can put anything to x, right? There's no restriction. So this is the whole thing. but the range is we'll take care of this range later on. Okay, so because let's see, we haven't talked about it yet. So just depending on what you learn in your high school, how's the graph of this f looks like if you graph them? This is a square.
Parabolic.
Parabola. Yeah, there's a parabola. This is a parabola going upward. Okay, opens upward. This means you have 3 here and -1. Right, so you have something that looks like this one. So this is in the middle. Right. So this should be, the first x should be in the middle. So in the middle is 4. So this is 2. So this should be 1 here. Okay. So the lowest of this point is, anyway, we'll talk about it in more detail later. This is the point, this is 1. So what is this one? All right. Well, plug in 1 here. If you plug in 1, then you get 1 minus 2 minus 3. Okay, so you get let's see. Is that correct? Okay. Plug in 1, 1 minus 2 minus 3. Oh, okay. Minus 1 minus 4. Right? So this is minus 4. Okay, so the range is everything's here. Okay, so the range is there. Okay, while for G, well, you can only plug in non-negative numbers and the same as the range. Okay, just draw the diagram. Is going to F going first. Let's see, what about the G? Let's compare RF and DG here. Compare this one. So RF is bigger than DG. So DG is, because this is from 0, this is starting from -4. So DG is just part of this. Okay, so here you have the G intersect RF is, see, just going from here is there. Okay, so what we have here is that so we compute G of F. The formula is G of F of X. F of X is, right? So this is so what we have so far. Okay. what we have here is that, okay, so what we need is, let's see, so the domain of domain of this is the set of X for which image. Let me write this down. The pre-image of this one. Okay, so this is the pre-image. All right, so this basically tells you that so f x squared minus 2x minus 3 is between 0. Yes, that's the thing. Okay. All right, so this is what we deal with. So with 2x minus 3, we're looking for x so that this is the value of this is positive. Sorry, not negative. Let's see. So this is plus 1, x minus 3, right? So a sign chart. Your sign chart is -1, this is 3. What about the sign? Of course, it's plus. Okay, so what we have here. So this is what we have. Okay, so this gives you and from 3 to, so that's the domain of this function of the compositions. Okay, questions? All right, so enough about the domain. Okay, but the important thing about composition is it's not the composition itself, but decompositions. Okay, in composition, you start with the say simple functions, and you get more complicated one. Decompositions means the other way around. That means you have a kind of complicated expressions and try to describe it in a simpler way. And actually, later on, we'll see that decomposition is used more, actually, more often in calculus. More often in calculus. That is how to write the complicated functions. As a compositions of simpler ones. Okay, so example. We try to rewrite these functions, for example. Let's see. Okay. So when you compute this kind of functions, just recall how you would use your calculator to compute this number here. Okay. So if you have a calculator and you have to compute, for example, all right, so plug in 7 to this functions. What would you do in if you use calculator? What to punch first? What to do? If you need to compute this one in your calculator, what to do?
Punch function first.
Which one?
I never use the calculator.
So for example, you need to compute this. Use calculator to compute this. What would you punch to your calculator?
The square root first.
Square root of what?
Square root of 7 cubed plus 1.
All right, so what's to compute first?
The 7 cubed first?
Right. So take your calculator. Pick your calculator, pick your smartphones. Opens the calculator apps.
Okay.
And compute that one. Right? So what would you do? Right? So compute what first?
7 times 7 times 7.
Right? So 7 cube. Right? Then what?
Yeah. At 1.
Add 1. And then?
Square it.
Right? So this is the order of what you do. Compute 7 cube. Add 1. Square root. So this is how you proceed. Then you can decide, all right, so compute this one. So let's, the first one is compute the cube. Right? It doesn't matter, you use X or whatever letter you like. Right? The thing is, you cube them. Second step, add 1. Right? Third step, take square root. Okay, so that's how you get this one. So if you apply this in order, so G1 first, and then G2, and then G3, apply to X, this is what you get. You apply Q, so cube, and then add 1, and then take square root. Okay, so this is what you have. Okay, so decompositions means writing in simpler forms. Okay, and this is not unique actually. You can also compute this in, let's see, what if we just use 2 functions? So if one is just, why not using this one? Okay, same thing. Okay. So the composition is not unique. Let me here we find some let's see, at least two ways to write down these functions. Okay. All right. So when you do this, just remember calculator order. Okay. All right. So that's what we call the compositions. Okay, questions? All right. If not, let's do some graphing of functions. Okay, a graph means, well, you know how the graph is. What we need is a Cartesian coordinate. Means you have two axes. The horizontal one called X and the vertical one called Y. Okay, and a point. For example, this is X naught and this Y naught has a coordinate. Okay, this is called coordinate. Okay, and with this coordinate, this is for X positive to the right. To the left, here is the, also this is the origin. Okay, so the zeros of the coordinate. Okay, so you have a what we call the quadrant. Okay, so this is the first quadrant, this is second quadrant, this is third quadrant, this is the fourth quadrant. The first quadrant is where the X positive, Y is positive. Here, the third quadrant means you have X negative and Y also negative. Okay, so I guess you're familiar with this one. Okay, let's do some graph of the functions. So what is the graph of functions? Of graph of function f is the set of xy. So set of coordinate in which y is the value of the functions. Okay, so I guess yesterday you learned about, with Kakema, you learned about linear functions. That is, usually we write something like this. Okay, so this is what we call a slope-intercept form. What we call slope-intercept. Slope is m. The intercept is b. what we call this intercept. Why is B is intercept? Oh, we'll see that in a moment. All right, so the graph should be right. Now, the easy thing that makes things easier is that a line is only determined by 2 points. Okay? So you need only 2 points to draw this one. Okay. Let's see, if you plugged in these lines, y lines, well, let's see. Okay, so plugged in x equals 0. When you plug in equals 0, then y equals b. This is what you call intercept. Okay, so here is the y-intercept. Okay, so that's why it's called a slope intercept, because b means the point here. Okay, for positive, and b negative, that's below the x-axis. All right, so m tells you how the lines tends to, whether it's decreasing or increasing. So if m is like positive, then the graph is increasing. Okay. So here, for example, okay. So here's m positive. If m is negative, this is okay. Okay. And sometimes you have lines with this one also. Let's see. This is the point slope form. Point slope form means that lines with given given slope m, which passes through the points, say x naught, y naught. Okay, so the form should be something that looks like this. All right, so this is what we call a points slope form. Right? So the slope intercept is a special form for the point slope. Okay. In this case, the point should be 0, p. Okay, so if you plug in 0 here and b here, you get this point slope formula. Okay. Okay. So this. All right. So let's do some simple graph functions. One that you should know So this is linear. And you have I should say something easier than this one. Simpler means this one. Okay. And let's see what else. Okay. Y equal. Okay. This is all right. So the first one. One, two, three, four, five, six, seven. Okay, so this is diagonal. This is minus x is diagonal. Also the other diagonal. Okay. This one's okay. This is the x squared. X squared. Cube. Cube is this one is negative. Let's see. What else? Oh, absolute value. Remember, absolute value is the one in negative part looks like negative x. So this one. For positive x, it looks like this one. So the graph is looks like this one. Okay, and let's see the three more. For this one, 1 over x. Let's see, 1 over x is okay. In this case, would be the x-axis would x-axis would be the horizontal asymptotes, and the y-axis is horizontal asymptotes. So we just recognize from here, but we need limit for defining asymptotes later. Okay, for square is this one. Okay, and square root is this. Okay, I think this is what you need to know about the graph of simple functions. Okay, questions? Okay, let's we'll do some transformations to get more complicated graph than this one, but we start with this. All right, so let's take a break for 5 minutes.